Welcome to my new video. Our today's question is replace non-coprime numbers in array. This question mark as a hard, but this question is not actually hard. This question is easy to medium actually, okay? Just because this question is a combination of three questions, two easy and one medium question. The question itself is a medium and we have to find GCD and LCM of the numbers. So both the question are in easy category. Let's see, like you have to perform the following operation. Before that, thank you so much for everyone. We just completed 100 subscribers. Thank you so much, everyone. Okay, so let's start the question. We have to perform the following operations. Find any two adjacent numbers in nums that are non-coprime. So we have to find the two numbers, any two numbers, and that has to be adjacent. Okay, that must adjacent and that are non-coprime. Non-coprime numbers like x and y are non-coprime if the GCD of x and y is greater than 1. So we have to write the function to calculate the GCD, and after finding that after find that two numbers, we have to replace them with LCM. Okay, least common multiple. If like such numbers are not found, we have to stop the process. Okay, let's first understand the LCM, how we can calculate LCM. So before, if you are new to the channel, make sure to hit the subscribe button. Okay, so GCD of A and B we have to calculate, right? So GCD of A and B is nothing but GCD. There is a trick in mathematics. Okay, this is the mathematical proof. We are not going to go in the proof. Like A becomes B and B becomes A mod B. Okay, GCD of A and B is GCD of B comma A mod B, and whenever B becomes 0, A is the answer. A is the GCD. Okay, so we can write simply function int GCD of A comma B. Okay, so until we have to we have to swap the values of A and B until B becomes 0. Okay, B becomes 0. What we have to do? We simply convert our B to A mod B. So our B value is A mod B, and we can store it into the temporary variable. Okay, A becomes B, and B value is A mod B, and A mod B is nothing but temporary. Okay, so we can just close this function. So this is our GCD function. We can simply write this function. Okay, now let's try to understand our LCM function. Okay, LCM, guys, LCM of any numbers, like LCM of A and B, least common multiple. Okay, LCM of any two numbers is nothing but, in mathematics there is a formula, LCM of A comma B multiplied by GCD of A comma B is equal to A multiplied by B. This is the formula. So LCM of A comma B is nothing but A multiplied by B divided by GCD of A and B. GCD of A and B. Okay, so this is the formula for our LCM. Okay guys, I hope you are understanding. Now let's see how we can solve this question. Okay, so you have to find any two adjacent numbers in nums that are non-coprime. Okay, so we just discussed how to find the non-coprime. Like we have to calculate GCD of x and y. If GCD of x and y is greater than 1, that means that numbers are non-coprime. Okay, if such numbers are not found, we have to stop the process and return our list. Okay, return our array. Otherwise, delete two numbers and replace it with LCM. Repeat this process as long as you find the adjacent non-coprime number. Okay, and finally return the modified array. Okay, now let's understand the question by taking the example. I am going to explain the question in very easy manner by taking the examples. Let's see examples, the modified example. Okay, I am not going to use this example. Okay, I am not going to use. Okay, similar kind of, so you understand more deeply. Okay, so example is 2 3 4 6 7 8 6 2, and here is like 8 9 5. Okay, let's see, this is the example. Okay, this number is 4 not 4. Okay, 7, this is 7. Okay, let's see guys, this is our example. Now what we can do, we can write one function that will give us two non-coprime number, and that function will what we do, just we have to simply traverse on our first I is equal to 0 to last number minus 1. Why? Because if there are 10 numbers, there are 9 pairs. Okay, for 8 this is the pair, for 9 this is the pair, for 7 this is the pair, for 8 8 and 6 is a pair, for 6 6 and 2 is a pair, but for 2 there is no pair because this is last element. Okay, so we can simply travel from 8 to 6 and we get every adjacent pair, and then we can simply check, we can pass these two number to our GCD function, and if our GCD is greater than 1, then we can compute on this. Okay, then if these two numbers, let's see, 8 and 9, these are not non-prime number. Okay, because the GCD is not greater than 1. The first pair is 4 and 6. Okay, like 4 and 6, it GCD is 2. Okay, and 2 is greater than 1, that means we have to replace that, like 4 and 6. Now what we have to do, we have to replace the two numbers with LCM, and LCM of these two numbers is I think 12. Okay, so we can simply delete these two numbers 4 and 6 and insert 12 over here. Okay, then we are again traversing on our array and finding two adjacent numbers that are which GCD is greater than 2. Okay, so sorry, 1. So the two numbers are again 12 and 3. Okay, not again 3 and 12. Okay, so 3 and 12, their GCD is greater than 1. Their GCD is I think 3. Okay, 3 is greater than 1, so this is fine. Now let's see what is their LCM is. LCM is 12, so we have to remove that two numbers and insert 12. Okay, now again we are traversing on our array, finding the two adjacent elements which are coprime, so non-coprime. So this is like 12 and 3. So 12 and 3, sorry, 2 and 12. Okay, their GCD is 2, which is greater than 1. So their LCM is 12. So we are again replacing it with 12. Okay, so this is our brute force solution. Okay, so I hope you are understood this, because we if then this solution will give us TLE. So we like, so optimize this you have to understand this very quick, very deeply. Okay, and we are just finding the two pairs until there is no pair. Okay, now let's see, next pair is 6 comma 2, and then next pair is 6 comma 8. After converting everyone, okay, our array becomes like there is a 24. Okay, so this is our final array, and there is no such pair. Okay, no, this is like 24 and 12. So again the GCD is 24, so we can just convert this into 24. Now there is no two adjacent numbers which GCD is greater than 1. So let's see the solution. Okay, let's see the solution. Okay guys, this is the solution. Let's see what we are doing. This is the list, we are converting every number, inserting every number into the list. Okay, then we are doing the process until we are finding out two adjacent non-prime integers. Okay, so this is the function find non-coprime numbers. Okay, so we are just traversing on our list and finding out the GCD. If GCD is greater than 1, we are just simply returning the index instead of numbers. Okay, then if we are traversing on entire list and we are not able to find two adjacent non-coprime numbers, we are returning -1. Okay, if we are returning -1, we are simply return the list. Okay, this is the given in the question. Let's see here, if no such numbers are found, stop the process and return the list. Okay, we are just returning the list. If okay, then if this is that not -1, that means these two numbers are valid. So we are finding the LCM of that two numbers, and this is the LCM. Let's see, this is the LCM, and LCM is nothing but like number 1 multiplied by number 2 divided by GCD of two numbers. Okay, this is This is the okay. LCM of two numbers is uh, n in n into so number 1 multiplied by number 2 divided by is GCD. We are discussing our explanation. Okay, divided by GCD. GCD is GCD of number 1 and number 2. So now we have our LCM. Okay, so what we are doing? We are doing removing the two numbers and inserting our LCM. Instead of removing two numbers, we are removing one number and we are replacing one number with LCM, and we are doing this until our we don't find our two adjacent non-coprime numbers. Okay, when we return -1, we are doing that, but this solution gives us TLE. Why? Let's see. Now we are going to move on the optimal solution. Okay, okay, this is the, let's see why this solution gives us TLE. Let's again take that same example. Okay, I written over, I think here. Okay, no, I don't write. Let's take this example again. Okay, 2 3 4 12 7 8 6 2, and there are like 5 8 9 7. Okay, so this is the same example we just discussed. Okay, let's see what we are doing. We are traversing on our array and finding the pair which are non-coprimes. So when we find this pair, we are just deleting this and inserting the LCM, right? Now again we are traversing on the array and finding the two pairs. Now we are again deleting and inserting its LCM. So you are seeing that what the mistake is here. Just a minute. Okay, what is the mistake? We are again and again and again traversing. Like when we got our first two non-prime pair. Okay, if we delete this and insert 12 over here, what is going to be happen? Okay, don't think about these numbers now. Okay, for now just think about back numbers. Okay, next, just don't think about next numbers. What is going to change if we delete 4 and 12 and insert its LCM, that is 12? What is going to change? It's only affects its neighbors, guys. It's affects 3. It's only affect 3. So what we can do, instead of doing like 4 and 12, instead of every time checking, what we can do, we can traverse on this numbers array. Okay, this array from starting. Let's see, our array is this. Okay, this is our array. We can starting from our, okay, when we got our first pair, we are doing the same process until we are finished out. Okay, let's see how we can do that. Like our I is 0, so we are just simply inserting into the list. Okay, let's write list over here. This is our list 2. Okay, let's see, can 2 make pair with anyone? No, guys. 2, the like a list for 2, list is empty, so we are not going to make a pair. To make pair, we want at least two numbers. Okay, so we can just simply insert in our list. Now our I pointers came to here. Now what we can do, we our list is not empty, guys, here. So we can make a pair with which the last element of the list, which is 2. Okay, so the pair is 2. We can make a pair with the last element of list, which is 2, and the current element is 3. Okay, this is like a current element. So pair is 2 comma 3. The GCD is 1, and which is not greater than 1, so this is not a valid pair. So we can simply insert 3. Okay, now our I is going to point to 4, and our current is 4. Okay, and the last element of the list is 3. So the pair is 3 comma 4, and which GCD is also 1, and 1 is not greater than 1, so this is not also valid. So just we are going to just simply insert 4 into our list. Now move on to the next part. Okay, this is 6. Okay, 12, we write 12, but this is 6. Okay, okay, so now our current is 6. This is the important part. Okay, and last element is 4. Now what we can do, our pair is 4 comma 6, which is with GCD is 2, which is greater than 1. That means we can compute it. Okay, so what we can do, it we can swap it with its LCM. Okay, now for now we are not going to insert 6 into our list. What we can do, this is our current is 6. Okay, so we can just delete our 4 into the list. We can delete 4, and what we can do, we can change our current to its LCM, and LCM is 12. Let's see what we are doing. We are doing, we don't want to compute again and again and again. Okay, so now let's see, our list doesn't empty. Okay, our list is not empty still, so we can make, still we can make a pair. Okay, still we can make a pair. So last element of the list is 3. The last is element is 3. Okay, so the pair is 3 comma 12. Okay, and which GCD is 3, and 3 is greater than 1. That means we have to replace these two numbers with its GCD, which is 12. So we have to delete 3 and replace it with 12. But again, we are not inserting 12 because we can compute. Now we can again compute till our list becomes empty. Okay, so our current becomes LCM, and LCM is 3. So the last element, and again the list is not empty, so we can again traverse, and the last element is 2. Now the pair is 2 comma 12. Okay, and our this all converts to this. Okay, 2 comma 12, the pair is 2 comma 12, and the LCM is 2, which is greater than, sorry, GCD is 2, which is greater than 1. So we have to again swap it with, like replace it with its LCM, and LCM is 12. Okay, LCM is 12. So what we can do, we can simply delete these two numbers and swap it with 12. You are understanding, we are not computing again and again. Why? Because searching into the array is costly. So like if when we convert, like swap two numbers, it affects only its neighbor. So we are just replacing until we can. Okay, so our list becomes empty. Now we are deleting two, and our current is, we can replace our current with LCM, and LCM is 12. Now let's see, our list becomes empty, means there is no number, so we can insert the 12. Now our next pointer is 7. Okay, 7. So the two pairs, which the two pairs are 7 and 12. Okay, their GCD is 1, and 1 is not greater than 1, so we can just simply insert the 7. Now our next element is 8. Okay, so which 7 and 8, 7 and 8 are also not, GCD is not greater than 1, so we are simply inserting 8. Now next pair is 6, sorry, 8 comma 6. Okay, which is just with GCD is greater than 1, so we can again compute. So this is our approach. Okay, so let's see how we can code it. Okay, let me show you the code. So what we are going, we are just simply traversing our numbers, and this is our current number. We are doing until our list becomes empty. The last number is list dot the last number. Okay, this is the last number, and GCD is, GCD of two numbers is this. Okay, GCD is two numbers are last number and the current number. If the list is empty, we are just simply adding the number. Okay, now let's see, if the GCD is equal to 1, or GCD is less than equal to 1. Okay, the least GCD is 1, so we can write it. So we are just breaking. Okay, and now our current becomes, we have to swap these two numbers with the LCM. So we are just deleting the last number, and our current becomes LCM of that two numbers. Okay, and LCM is nothing but A multiplied by B and divided by G. Okay, this is our LCM, right? And we are not inserting our current into the list because we can pre-compute until our list becomes empty. And second condition of breaking is GCD. If our GCD doesn't make, we are still breaking out this loop and inserting our current element. Okay, by doing that we are removing unnecessary traversing on our array. After that we are returning our list after traversing in entire nums array. Okay, let's try to run it. Yes, it's running. And if you are new to the channel, make sure to like, share and subscribe. Thank you so much for watching.